Hello everyone. Today I'm going to talk to you about focused live programming with loop seeds. The context here is live programming, in which runtime values are always on display. The way this typically works is that programmers provide function inputs, and the system runs these functions on these inputs to generate the runtime values to display. Today I'm going to show you that such function inputs are insufficient in some cases, and I'll describe a solution to this problem. Let's take a look at an example. So here I'm going to be doing insertion sort. So I have a function called sort that takes a parameter L, and I have a test input, which is the list 827. I'm going to start a result list with the empty list, and then I'm going to take every element of L and insert it into R while keeping R sorted. So let's iterate over all the elements of L. And over here, what you'll notice is a box appeared. This box is called a projection box, and it shows a programmer the values of all of the variables that are in scope. This is a live programming environment that I'm going to be using to explain all the ideas. So here I'm going to, my goal is to insert X into R while keeping R sorted. So to find the right location to insert, I'm going to iterate over all the indices and the elements of R. And when I do this, you'll notice that something odd happened at this line here. I don't have any live data at this line. I don't have any projection box at this line. Why is that? Well, R starts off as the empty list, and because the program is incomplete, R never gets modified again, and as a result, this line over here never gets executed. More broadly, the problem is that values in a loop are sometimes generated by the loop itself. So when the loop body is incomplete, values in the loop might be incorrect or missing altogether, and we call this the loop-datavoid problem. Our solution to this problem has two components. The first one is what we call loop seeds. These are values of loop variables to start a hypothetical loop iteration. So let's take a look at what this looks like. So here I can provide a loop seed for R. Let's say I'm going to provide the list 1, 3, and for X I'm going to say that X is equal to 2. So at this point you'll notice that the loop body is visually focused in the sense that the rest of the code is grayed out. But more importantly, there is a data focus. Notice how the projection boxes are now displaying the live data for the loop iteration, for only the loop iteration that was started by the loop seeds. Most importantly, notice how R here used to be the empty list, but now it's not the empty list anymore. And as a result, if I go to this line over here, I now have live data here, and I can use that data while writing the code to help me. So the second component of our solution is this programming mode I just showed you, and it's called focused live programming with seeds. It's a programming mode that focuses the programmer's attention on the hypothetical loop iteration that was started by the loop seeds. So now let's go back to our code. I'm going to finish writing this, but I'm going to do it real quick by just pasting the code in. Now don't worry, you don't have to follow all of this. I know this went really quickly. The most important thing here is that because of loop seeds, I had live data to help me write this code. If I didn't have loop seeds, R would have been empty throughout this whole writing process, and as a result, I would not have had any live data to help me write the code. Once I'm done writing the loop body, I can test it out by modifying the loop seeds. For example, I can test out with x equals 0 and make sure that the loop body works correctly. I can test out with x equals 10, make sure that the loop body works correctly again. And when I'm done and I've tested it properly, then I can escape out of this mode, and now I can see the live data for all the loop iterations, not just the loop iterations from the loop seeds. And finally, I can also go at the end of my function here and make sure that in fact the list I get is a sorted list. So we implemented this approach and we evaluated it in a small lab study with 10 subjects, which showed a few things. Programmers found our approach helpful and easy to use. Programmers also had better loop data by using our approach than without our approach. And finally, our approach was also useful for reducing information overload, code debugging, and code understanding. In summary, we identified what we call the loop-datavoid problem, which happens when a loop body is incomplete, and as a result, the live values in the loop are either missing or incorrect. We presented a solution called focused live programming with loop seeds, and we evaluated the solution in a lab study. Thank you.